Good morning, everybody. Thanks for joining us today for this webinar, Winter and Summer Best Practices. My name is Jackson Piper. I'm a program coordinator with the Center for Transportation Studies at the U of M. Before we get started, I just have to give a little spiel about CTS and what it is that we do. Again, I'm with the Center for Transportation Studies, and within the Center for Transportation Studies, I'm with Minnesota LTAP, which is the Local Technical Assistance Program. What LTAP does is provide training opportunities through the year, which include big annual events, technical workshops, and self-paced online courses, kind of like today's webinar. Within LTAP, the biggest thing that we do is the Rhodes Scholar Program, which provides training and professional development opportunities to local agency staff through certificate programs. I'm sure a lot of you guys listening today are already enrolled in the Rhodes Scholar Program, which is great. The one that I'm going to talk about briefly today is the Maintenance and Operations Technical Certificate, because this webinar counts for those credits. If you enroll in the Maintenance Operations and Technical Certificate, you need 8 credits within 5 years to graduate with that certificate. And again, today's webinar does count for that. You get 0.5 credits towards the 8. So when you're done with today's webinar, please send an email to mnltap@umn.edu to receive credit for today. Please, 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 please do not email my personal email that you've been getting the Zoom confirmations from. My email is a disaster. So please email this shared inbox to get credit for today's webinar. There are some other upcoming in-person and virtual workshops scheduled. You can see here, work zone safety overview, truck weight education. We have a whole list online. If you take a look at our training calendar, there's a link here at the bottom. You can navigate for a website, mnltap.umn.edu, and you can see all the trainings that we have coming up this spring. Now, some logistics about today's webinar. We are in a Zoom webinar function, which means that you can see and hear us, the panelists. We cannot see or hear you. So if you would like to communicate with either us or anybody else that's participating today, you can do that through the chat function. You can share ideas with everybody or let us, the panelists, know if you need technical assistance. On the other side, there is the Q&A. That is how you can ask the panelists or the speakers today any questions. I and the other panelists will be monitoring the Q&A, and we will have time for questions later on. There are 2 parts to today's webinar. The first part will be about winter maintenance, and the second part will be about improving unpaved road performance. In between, we'll take a little 5-minute break. And at the very end of today's webinar, if you're interested in hearing about any of the enhanced or special products that the panelists have mentioned throughout the webinar, there will be time at the very end to hear about those products and to ask any questions about those products. Now, I'd like to welcome our 3 panelists. We're joined here today by Mike Coffey, Steve Clark, and Bill Langren. They are all with Envirotech Services, and I am going to turn it over now to Mike.
All right, I'll get this going here. Mike, we're going to try to share our screen again like we did last time. Hopefully it works. All right. Just for everybody on the Zoom meeting real quick, we tested this last week and it was flawless. We tested this for 10 minutes prior to the meeting and we had issues, so we'll see how it works. Give it a shot, Mike.
It's not working.
Yeah, it went.
Oh, there it goes.
Yep.
Okay, there we go. We're good. Okay. Well, thanks, Jackson, and good morning, everyone. Great to be with you this morning. I have a lot of ground to cover, so I'm going to actually just jump right into things. I'm going to be talking to you about winter maintenance best management practices. There are a lot of those to choose from. And what I've done is I've gone through and I've selected, I think for me, 9 of what I consider some of the most impactful best management practices that you really get a lot of bang for the buck out of these best practices. And it truly, these, if you implement these operational tactics, you um, you really can do more with less. And that's kind of a theme. And that's something I always try to, a goal of mine is to do more with less, because most government agencies are under a lot of financial pressure. And so doing more with less is kind of the way we have to do business nowadays. Oh, now it's not moving. Sorry, everyone. I'm having technical problems still.
Hey, Mike,
Yeah.
how about it? I'll just click. Let me
Okay.
just do it.
Okay. Yeah.
Um, I'm gonna stop remote control E so I can click it. Okay. All right.
Okay, so just a brief introduction. So again, my name is Mike Coffey, uh, currently a technical expert with Envirotech Services. Before I came to work for Envirotech about 6, 7, 8 years ago, I spent 37 years with the Alaska Department of Transportation and Public Facilities. I started on the engineering side of things, and then discovered maintenance and operations and fell in love with it, and spent out of my 37 years, I probably spent 30 of those years in maintenance and operations. Spent about 11 to 12 years as the director of statewide maintenance and operations, and have worked in Fairbanks and oversaw the Arctic operations. And so winter ops has been a specialty interest of mine for just about my entire career. So uh, I'm an APWA instructor. I've done LTAP training across the country, and I'm also a member of the APWA, American Public Works Association Winter Maintenance Committee. So just a quick background next. And so whenever I'm doing a presentation on winter maintenance, I always like to kind of remind folks why we or why you do what you do. And it's, first and foremost, it's to, to avoid having these sort of nightmare scenarios of these pictures on the screen. Next. So, oh, go back one.
Okay.
So, in winter maintenance, our goals first and foremost is safety. Another goal is also mobility. We need to keep our road network open so commerce can move, the traveling public, people can get to school, people can get to work, people can go visit grandma. So, safety, mobility are our primary goals in winter maintenance. We need to provide that safety and mobility while minimizing impacts to the environment. We need to do this, provide the safety and mobility within budget. And I'm going to guess that nobody on this webinar's agency has excess money to spend. Um, we need to provide the right level of service, which means addressing the social impacts or social expectations of your community. We could talk for a whole day on this subject, and the only thing I'll say is dealing with the social expectations of our communities. That's very complex because every community is different. So, and then the other thing is winter maintenance. It's a systems thing. You guys probably know this much better than I do, but if you take resources from one road and put them on another road, you're impacting other roads within your network. So decisions you make aren't just standalone that affect, road A. When you move resources around it, to provide a higher level of service on one road, that inevitably impacts other roads within your network. So it's a systems thing. And we talk about all of this, and this brings us to a word, which is sustainability. Really, there's a lot of pressure in society today for sustainable practices, and that's the same in public works with winter maintenance. And really, what it forces us to do is to think, how are we going to provide our standard level of service while minimizing, again, impacts to the environment? And it can be tricky, but we can improve things by implementing best practices. And that's what we're going to talk about today, is those best practices that can help give you a sustainable snow fighting operation. So again, a lot of people freak out over sustainability. All it really means is that we have a balanced approach to winter maintenance. We have, we don't put too many eggs in one basket. So if we put all our eggs in the environmental basket, you can have zero impact of any kind. That's not going to be sustainable. So again, where the economy, the societal impacts, and the environment kind of all come together, we get that sweet spot with it, which is sustainability. So bottom line, sustainability just means we have a balanced approach to winter maintenance. Okay. Okay, one more. So one thing in winter maintenance, it's important to start off with a comprehensive snow and ice control plan. These are critical for state, county, and municipal transportation agencies. They ensure safety, maintains mobility, and optimizes the use of limited resources during winter events. The typical snow and ice control plan has chapters within it. It addresses reason and authority, goals and objectives that you're going to provide. It outlines strategies, tactics, resources, and it offers protection from liability. And as somebody that sat in many a witness stand in courts representing the state of Alaska after accidents and all, having a comprehensive winter maintenance plan while sitting in that witness stand, that was kind of our saving grace. And as long as you have a plan and you follow it, it is a great, it protects you from liability. So very important. And then the most important element of the winter maintenance plan is the defined levels of service. Okay, Steve? So these are pictures of different levels of service. This actually comes from our Alaska maintenance manual. And so what is level of service? Level of service defines the expected condition of roads, sidewalks, bike paths, parking lots, if you maintain parking lots. It defines the end state. What are you shooting for? So when the last snowflake falls and your operators are out on the road, how do they know when they're done? There's a saying that if you don't know where you're going, you're going to end up someplace else. And so we want to be having a defined level of service lets us know what condition of the road are we attempting to get. Is it bare pavement? Is it wheel tracks bare? Is it just compact snow and ice with traction material applied? So, and then is it within 5 hours, 6 hours, 12 hours? So that essentially is our levels of service. It defines the end state that we're shooting for so that we know when we're done with our response to the storm. Okay. So levels of service truly are kind of at the heart of our winter operations plan, and they should essentially drive just about every decision we make in winter maintenance. So if we have bare pavement policy, that pretty much dictates that we need some sort of chemical in order to get that bare pavement within a reasonable amount of time. If we just need, compact snow and ice with material sand spread, we don't necessarily need a chemical. In fact, we wouldn't want to have a chemical under that circumstance. So it again, it drives our decisions because the ultimate goal of what we're doing is to get that level of service. Levels of service are very road specific, very location specific. Again, what works in Minneapolis is not going to work in Shorewood. It's not going to work in Auk Bay, Alaska, where I am from, and it's certainly not going to work in Georgia. So again, having a really well crafted definition of your level of service, what your target is really crucial to world class, as I like to call it, winter operations. Okay. So the overarching goal of winter maintenance is to provide that defined level of service as efficiently and effectively as possible while using the least amount of material needed to meet that target LOS. That's being good stewards of the environment. And we need to do that within the time frame defined by your stated levels of service. Okay? So, how do we improve the efficiency of our material applications to minimize the amount of material that we are using while still meeting our defined levels of service? This is where implementing best management practices really comes into play. This re- Implementing, like I say, there's a multitude of best management practices, and the more that we can implement, the more effective and efficient our operation is going to be, and the more sustainable we're going to be. And again, by having well-defined levels of service, we've already covered the first step. So next, so when it comes to winter maintenance, it's all about providing friction. So we need to get people from point A to B, and we do that by providing friction in winter maintenance. Okay. There's lots of ways that we can provide friction on the road. We have the mechanical snow and ice removal. That's using the plow. We can use granular materials, sand, abrasives, salt, treated salt, complex chlorides, and we have liquids, salt brine, mag chloride, calcium chloride. Those are kind of the big three winter maintenance chemicals. A major takeaway from this slide is that mechanical snow and ice removal always has been, currently is, and I'm going to argue will always be the primary way we remove snow and ice from the roadway. Everything on this slide except sand and abrasives is geared at making manual snow removal more efficient. Okay. Because when we're using chemicals, we're not using chemicals to try and burn off all the snow on the road. That would be we'd use an ungodly amount of material if we were trying to melt all the snow in our highway system. So it's all about the bond, the interface between the snow and ice and the pavement surface. We apply chemicals to either prevent the bond from happening, so to keep snow and ice from bonding to the road, which is anti-icing, and we're going to talk more about anti-icing, and it's used to break the bond if we already have snow and ice on the road and it's frozen to the pavement. So we add chemicals, again, not to burn off all the snow above it, but to just attack the bond to make snow and ice control by the plow to make it more efficient and effective. That's really a major takeaway. Okay. So again, we're not using de-icing chemicals to melt all the snow. We are using the chemicals essentially as a freeze point depressant. So we want to lower the temperature of the water, the snow and ice on the road to a lower freezing point. Okay. So again, we all know now, can you see can you see the cursor that I have? So I don't know if you can see I'm moving the cursor. So anyway, we all know that water freezes at 32 degrees. But if we start adding chlorides to it, and that starts depressing, this is the freeze point depressant, the water, instead of freezing at 32, it's going to now freeze at 40 or at 10 degrees. It's now going to, at 0 degrees. So that's what we're trying to do, is to lower the freezing point of the water and the snow and ice on the road. When you apply material like at 20 degrees, you have a fairly large range. So I'll use the example here of salt brine, which is a concentration of chlorides, 23.3% by weight. So if we apply that 23.3%, we're kind of up in this area here. We have a long way for it to start melting, because soon as our products start working, they start melting and they start diluting. And so we can see that we have a pretty good thing, and it'll actually, until it gets to a concentration of about 10, it's still going to stay in liquid form. It's not going to freeze. Okay, next one. But the colder the pavement temperature, you can see we have less room for the dilution to actually work for us. So we put the 23.3% down, and now at the time it gets to about 16% concentration, we stand the possibility of refreeze. So again, it's there's a lot going on in this slide, but the bottom line is just be aware that as soon as our products start working, they start diluting. And when they reach the temperature that the chemical is no longer effective, we have the potential for refreeze. So that's very important when you're putting, the chemicals down on the roadway. Okay. So with the various materials that we have several chemical application techniques. And just real quickly, de-icing is the historic method. It snows, we wait till there's 2 inches, 3 inches, 2.5 inches, whatever it is, and then we dispatch our trucks. The problem is, while that snow is on, that 1 or 2 inches of snow is building up on the road, vehicles are driving over it, and it's compacting it down, and it's bonding to the pavement. So that's de-icing, where you wait till you have a certain amount of snow that's already bonded on the pavement surface, and then we do our manual removal with our the blade. Anti-icing, that is a proactive method that we use, where we're putting down material ahead of the storm or at the very beginning of the storm to prevent the bond from ever forming. So that's again a very proactive policy or procedure in winter maintenance. And then we can pre-treat our material, which means we take a liquid, add it to a solid as we put it up in the stockpile. You can do that yourself you can add liquid to solid salt through like a road mix. You can use a pug mill, or you can buy it from a vendor. A lot of vendors sell pre-treated salt, so you can get it from a vendor. And then there's pre-wetting, and pre-wetting is actually done on the truck. So we have the truck full of salt, and we have saddle tanks on the truck. And as we're dispensing the sand or salt out of the back of the dump truck, we are adding moisture to that, and that's called pre-wetting. Okay. Okay, one more. So, this takes us to our second best management practice, and that is pre-wetting, pre-treating. Getting your material, if you want it to work, you got to get it wet. So, an important concept again is that dry salt does absolutely nothing for us. Until salt goes into solution, salt goes into a brine, it doesn't melt anything for us. So again, a lot of people think, nah, we don't do a liquid program because we just use, white salt. Well, the reality is that white salt doesn't start working until it has some heat applied, it has moisture applied, and it starts going into solution. Then it starts melting, which is what we want it to do. Okay. So pre-wetting is where we're adding a liquid chemical to salt or sand immediately before it comes out of the truck. Lots of benefits to doing that. One of the biggest benefits is it reduces bounce and scatter. So if you're taking dry salt or dry sand and you're putting it out of the back of the truck, a certain amount of that, and that's actually up to about 30% of the material, as it comes out of the back of the truck, it bounces off out of the traveled way to where it's not doing us any good. So by pre-wetting that material, you minimize bounce and scatter and can actually save about 30% of lost material, which is a great for the budget, great for the environment, when you're pre-wetting and you're minimizing the bounce and scatter. The other thing is, salt, again, dry salt doesn't do anything for us. So if we pre-wet it, the second it leaves the truck, it has moisture on it, it's going to start working quicker. So again, that's allows us to do more with less. Oh, go back one more time, Steve. So again, the key things on pre-wetting is it minimizes bounce and scatter. It jump starts the melting process. And if you're using a product like calcium chloride or magnesium chloride as your liquid chemical, you can actually lower the effective temperature of the salt. So instead of salt working at no colder than 15 degrees, you pre-treat with calcium chloride, you can drop that effective temperature down. Okay. So historically, we added about 8 to 12 gallons per ton for pre-wetting. Things are changing in recent years where kind of a more is better scenario. So a lot of agencies I deal with across the country, they are now applying closer to 20 to 25 gallons per ton. And the advantage of that, the more liquid you use, the less solids that you need to use. So that's a sustainable practice because you're using less chlorides going into the environment. Okay. So, and again, just an example of, so pre-wetting is when you do it on the truck. Pre-treating is when you are putting the liquid as you're putting it into a stockpile. Again, you can buy this. You can buy it from vendors. You can mix the material yourself. Okay. So again, why do we want to pre-wet or pre-treat material? Because we don't want to see this picture here. Again, dry salt doesn't do anything for us. So this material the salt we see here on the shoulder, it never went into liquid, so it never performed what we wanted it to do. So by pre-wetting, we could actually save 30% of the materials that we're putting down on the road. So that's 30%. That can be a significant cost savings to an agency if you're not currently pre-wetting or pre-treating. So the next BMP we're going to talk about is anti-icing. And this is another great efficiency that we can do that can save us a lot of money. So anti-icing, again, is applying typically a liquid, but it can be a pre-wet salt. We're putting it out ahead of the storm or just as the storm is starting to happen. And anti-icing, it prevents the bond of the snow and ice from bonding to the pavement. And anti-icing treatments are absolutely fantastic for frost formation, frost prevention. You can get a lot of bang for the buck with very little liquid application. You can manage frost very effectively. Okay. So again, anti-icing is proactive and it requires only about the quarter as much material as if you're de-icing. So de-icing takes about 4 times the amount of material as anti-icing, and that which makes sense if you think about it, that if there's a compact snow and ice on the road and all we are interested in is the bond, you're putting chemical down on top of the snowpack. It needs to melt its way through to get to the pavement, spread out, and break the bond. So again, comparing anti-icing with de-icing, anti-icing takes about a quarter as much material as it does for de-icing. Okay. So this is just an example. This was a picture I took in Alaska. This was a pre-treatment of salt brine with a boost additive. And this is kind of the classic anti-icing where you see there's no snow. You see some blue skies actually. So they're getting out ahead of the storm, getting the material on the highway so that when it does start snowing, the material is not going to bind itself to the pavement, and the plows can come through and be a lot more efficient in removing the snow off of the road. Okay. And then this is an example of, I believe this was for frost prevention. This was a Apex. Yeah, this was so 15 gallons per lane mile. This was mag chloride. This is Apex. It's a cold weather enhanced mag chloride. And this was right after it was put down. So you can tell it does not take a lot of material to be effective in frost prevention. So that's a real benefit to maintenance crews. Okay. Again, this just goes to when we're anti-icing, we're trying to prevent that bond. All we're really melting or want to melt, it's an area, it's about 1,000th of an inch. And so all we need to do is get some material between the snowpack or the snow that's falling, the pavement, and we're just attacking that snow and ice interface with the pavement. So again, I think that's when you think about that, it's pretty amazing. We're only melting about 1/1000th of an inch when we're anti-icing a roadway system. Okay. So brings us to our fourth best management practice, which is the use of liquid chlorides. Again, we've talked about salt, magnesium chloride, calcium chloride. Those are the big 3 in liquid chemicals. Okay. So why do we use liquids? So like we already said, dry salt doesn't do anything for us. So let's use a liquid to jumpstart the melting process of the salt that we're putting out on the road. We again want to achieve our defined level of service while using the least amount of material. And this is where liquid de-icers really shine. So I'm going to just a real quick thing here, a little bit of math, but at 23.3%, which is the ideal application for salt brine, we have a eutectic temperature of -6. Well, the equivalent of 23.3% salt in a solution is roughly 2.5 gallons of salt per gallon. So if we convert that 2.5 pounds per gallon to a typical application of by the lane mile, so 30 to 50 gallons per lane mile is a typical salt brine application. And so at 30 gallons per lane mile at 2.54 pounds per gallon, that's 76 gallons or 76 pounds of salt. Up to all the way up to 50 gallons per lane mile, that's 127 pounds of salt. A typical solid salt application for anti-icing or de-icing is between 100 and 500 pounds per application. So you can see we're putting down tremendously less chlorides when we're doing a liquid as opposed to a solid. And that is a very sustainable winter maintenance practice. Okay. So again, kind of a summary, why do we use liquid de-icers? They are extremely versatile. So we can use liquids for anti-icing. We can use them for de-icing. We can apply them directly to the road. We can add them to granular salt and sand for pre-wetting, pre-wet, pre-treating. They really make it easier for the snow plows and the graders to manually remove snow from the road. Great for frost prevention, minimizes bounce and scatter. Again, the use of liquids is something that's really caught on across the country and is expanding significantly in winter maintenance. So again, we have lots of lots of chemicals to choose from, particularly the big three. The main there are differences, but the main differences are effective temperature and application rates. So again, salt brine is limited to about 15 to 20 degrees on the pavement temperatures. Calcium chloride, magnesium chloride can be used at quite a bit lower temperatures. And the application rate of mag chloride and calcium chloride is pretty significantly less than that for salt brine. Okay. So I put this table together with just some kind of key facts, eutectic temperature, working temperature. So you can see the difference on working temperature, effective temperature. Salt brine between 15 and 20 degrees. Magnesium chloride works down to about 5 degrees, and calcium chloride about 20 degrees. And depending on the resource that you're using, these numbers do vary. Different, some people will say mag chloride can go to lower temperatures, or it shouldn't be used below 10 degrees. So you got to find use your own judgment, use what works for you. And then when you look at the common application range at the last column, you can see that salt brine application rates are significantly, I think, up to 25%, 30% more than if you're using a mag chloride or a calcium chloride. Okay. So salt brine is probably the most common anti-icer across the country. One of the things that a lot of agencies really like about it, I used it in Alaska, and the thing I like is you generally make it yourself. You can buy pre-made brine, but you can make, all you need is salt and water essentially, and you have a lot of control when you're using a salt brine maker and it's at your own facility. So again, the eutectic temperature is -6 at a 23.3 concentration. A key element about salt brine is that it is not hygroscopic. So calcium chloride and magnesium chloride draw moisture from the air. Regular white salt does not. So that, and you're going to see here on the next slide that can create some problems. And salt brine is limited to that 15 to 20 degrees pavement temperature, but it does have the great advantage that you can blend a lot of different materials in with a basic salt brine to gain a lot of different benefits, and we're going to talk about those here in a minute. Okay. So again, salt brine, because it's not hygroscopic, it doesn't draw moisture out of the air. It can tend to dry out and dries out and gets blown away. So that's a salt cloud on the picture on the right behind that truck. So because it tends to dry out and the salt can blow away, salt brine can require frequent application. Again, a lot of storms, if your storms are happening with pavement temperatures below 15 degrees, salt brine has its limitations. And then straight salt brine, that's one of the most corrosive products that we have in winter maintenance. So we got to be aware of that, both for our vehicles, the traveling public, and highway infrastructure. Okay. Okay, keep next one. So this brings us to best management practice number 5, which is liquid enhancers. And that's one of the great things about salt brine is that you can add material to it to gain lower effective temperature, to gain tactify, so that it'll be stickier on the road. You can get corrosion inhibitors, and then you can, if you have salt brine and you have an event where the pavement temperature drops below 15, you can add organics, you can add calcium chloride, you can add magnesium chloride to let that salt brine actually work at temperatures lower than the stated 15 degrees Fahrenheit on pavement temperature. Okay. So what's a salt brine enhancer additive? It's another component, usually in the 5, 10, 15, maybe 20% range, that we add to our salt brine to improve one or more of the different properties that we're looking for. There are agricultural products known as ag-based deicers, organic byproducts. These are all products from agricultural byproducts. So they can do different things for us. You'll see that on the next slide. There are polymer-based additives that are very important because they are engineered for consistency. And so with ag products, that's one of the challenges with ag products is they can vary from batch to batch. So again, on the sugars, the ag products, typical ones used are like beet molasses, the beet juice, corn byproducts, cheese making byproducts. The one I like the most, beer brewing byproducts. You get carbohydrates from fermented food waste. And again, you can get polymer based products that are engineered for consistency. Okay. And then again, the additives there's a lot of things that additives can do for us. And we have to determine when you're figuring out what additive you want to buy, you got to figure out first, what do you want it to do? Do you want to lower the effective temperature of your salt brine? Do you want to prevent corrosion? One of the most important ideas for me, or concepts for me, is the residual tackiness. So again, that adds the stickiness to keep the salt on the road. One of the examples I use is take a can of Coke or Pepsi, spill it on your desk, let it dry, and touch it, and it's sticky. That's the sugars. And so when we're putting that out, that helps us keep our product on the road and working for a longer period of time. And then there's, do we want the environmental benefits? We have to look at the life cycle cost of the product. Do we have the infrastructure and storage capability? Do we have the product even available within a reasonable distance so that it's not too expensive to get it to where you need it, shipped? Okay. So another really important best management practice is variable application rates. We don't want, every storm is different. And so shouldn't our applications be different? We want to take into account pavement temperature, precipitation type. Is it a wet snow? Is it a dry snow? We need to know cycle times of vehicles. How soon can the plow truck get back to that area to plow things? So again, variable application rates allow our different agencies to adjust how much salt brine, other deicers that are applied based on actual conditions. And so this has been there's been a real movement towards this variable application rates, dynamic spreading. There's uh, again, the main thing here is no two storms are alike, and every application should be targeted towards the specific storm, not just, okay, that we're going out, we're going to just, everything gets, 30 gallons per lane mile. We need that real world information to be more effective so that we're not over applying or even under applying, which can cause safety issues. Okay. And then there are manuals out there that can help you figure out good starting places for the different application rates. Federal highways, this chapter 6 application guidelines, that's a great document. A lot of agencies use that as kind of the basis. It lays out, a range of application rates for freezing rain, black ice, light snowfall, heavy snowfall, wet, dry, conditions. And then Clear Roads also has one of its research projects that has application rate recommendations. So you're not going at this alone. There's a lot of help out there, and highly recommend these two guides to help if you're just getting started in this. Okay. Another BMP is it's about pavement temperature, and any agency using de-icing chemicals needs to have information on pavement temperatures. Again, that's where things are happening. It's at the pavement ice snow interface. There's a lot of different pieces of equipment out there that will get us the temperatures, but this is a definite best practice that if you are using, whether it's solid or liquid de-icers, you need to know the pavement temperature. Air temperature is important because it tells you about trends. If you're putting down, you want to put down material and it's 16 degrees, so you're above the 15, but you have a cold front coming in and realistically your pavement temperatures are going to drop. You need to know that. So again, you want to know pavement temperature, you want to know the air temperature, but the pavement temperature, nobody should be I don't think no agency should be putting a chemical on the road if they don't have access to knowing what the pavement temperature is. It's a great best management practice. Okay. One more. So, and this is one that really surprises me sometimes, that I get fortunate and I get to travel around the country doing training, and there's still a lot of agencies that are not calibrating their equipment. And calibration of our equipment is one of the best practices I think that we can have. Okay. So we should be calibrating any vehicle that has a product, whether it's solid or liquid, coming out of the back of it. we need to know how much material we're putting out on the road. So a absolute minimum of annual calibration of equipment is crucial. In Alaska, we had long winters. So we always tried to do one at the beginning of winter where we calibrate all the equipment, and we tried to do one at midwinter because things do change. Anytime there's a significant mechanical change, a new hydraulic system, electrical system, anything like that, anything new of significance, a new auger size, you need to recalibrate your equipment. Don't forget your saddle tanks. And, if you have saddle tanks on your vehicles, they need to be calibrated. So liquids, solids, anytime there's a major change, we need to recalibrate, because if you don't know how much you're putting out of the back of the truck, you really can't manage that. And then one last thing on that is uh, if if you buy a machine right off the factory floor, the vendor may tell you, yeah, and it's all calibrated. The reality is it's not. It's calibrated for wherever that truck was made. We don't know what product they were running through the truck, because every product we use, salt, sand salt mix, everything flows through the truck differently. And so you need to calibrate for every single type of material that you're using on your trucks. And again, don't forget liquids. Okay. And then the last best management practice that we're going to talk about today is training. And do not overlook the value of training. And from a safety point of view, what you guys do is dangerous. And the more training that you can have to make you a better, safer operator, that's a win-win for everybody. So again, training should be extensive for new employees, refresher courses for veterans, and then if you have that problem employee that's maybe kind of accident prone, there should be some remedial training for those folks. um, Again, your snow and ice control plan, that's not just for upper management. Every operator should have access to and be familiar with your snow and ice control plan. That should be trained every year. If you utilize contractors for your to help you with snow and ice removal, you should be training them on the snow and ice control plan and just on the operations of the equipment. Um, and then your training plan should be updated annually. Okay. So, and again, there's really no excuse for not providing training, because there are so many options and things, training that's available out there for us. There's in-house training. Use your high skilled operators to train the new guys coming on board. Competitive events are great. The equipment rodeos, fantastic. They'll get a little competition going, and the new guys can really learn from this. There's a lot of computer based training from AASHTO, American Public Works Association, Clear Roads. In Alaska, because we were so spread out and it was hard to get to all the maintenance stations to do training, we actually developed a lot of our own videos and computer type training that we sent out to folks. LTAP, fantastic organization. Jackson was saying and showed a lot of the different training that they provide. Great resource. LTAP. YouTube, I think, is absolutely fantastic. I'm a YouTube fan, and I have actually, when back in the day when I was with the DOT, I bought several pieces of equipment and instituted procedures that I learned just because I was watching some YouTube shows. Simulators, a lot of that's available. And then don't forget vendor training. Again, in Envirotech that we all work for, that's what I do. So I'm basically a full-time trainer now, and there's a lot of vendors that will provide training. And the good thing for you guys is generally that vendor training is free. So with that, I kind of went through that pretty darn quick because I wanted to get all of that in for you. If you have any questions, you can put those in the Q&A box or the chat, and one of us hopefully can answer the question. Any questions out there, Steve or Jackson?
I'll wait for another few seconds, but none relevant to your presentation, Mike.
And I'll just say one thing. It'd be interesting if you can take the time to, so those are 9 of the big best management practices that I think are really important. Maybe just jot down what you guys think, or is a great, something you guys are implementing as a best management practice. And maybe that's something we can share with others at other training. So again, I had my top 9. Love to hear what your guys, top 5, top 6, top 9 best management practices are.
Okay, Jackson, do you want us to do a 5-minute break?
Yeah, that sounds great. Mike, if you are all set, then we will take a 5-minute break to hit the bathroom, refill some coffee, and we will reconvene at 11:06, 5 minutes from now.
Okay.
Okay, so there's been 6 people drop off. Let's see what's in the chat. I'll answer that question later. What was it? Hey Jackson, we're back.
Okay. And it looks like Mike, are you back?
Yeah. Okay. Yes. All right.
Okay. It looks like we have one question in here for Mike from his presentation, but we can circle back to that at the end.
No, but let's go ahead and do it. We'll
Is he
since
is
we
he here?
just- Yeah. Hey Mike, you gotta unmute. Well, maybe he took his bio break. So let's circle back to it.
We'll circle back to that.
Yeah. Yeah, just so everybody knows that's listening right now, Mike is in about the most northwest part of the state of Washington you can get. So he is remote. There he is. Yeah.
Mike, feel like answering a question before we get going with Steve and Bill? Can't hear you.
Oh, I heard my name, so I figured I better come back and check.
Yeah, you have one question here. Are you able to see the Q&A?
I can't.
Okay. Can you
Okay, Steve, would you read that? Do you mind reading that question out?
Go ahead if you can see it, Jackson. We're having difficulty with a little technology on our end too.
Sure. Okay. The question here is, can you talk a bit more about how anti-icing rates compare when you're using different products? You described how, and there's MG.
mag
Oh, mag
chloride
chloride
and
and calcium chloride.
Yep. Thanks. How those things use lower direct liquid application than salt brine, but I'm wondering what the application ranges are for anti-icing.
So, and again, every location is different. You know, every storm is different. That's why there's always a range of potential application rates. So, what I'll just say, this is my personal experience. This, you know, others what could have a completely different experience, but like on mag chloride, calcium chloride, a lot of times I hear from, you know, agencies and in my time with Alaska that we start off kind of in the 20 to 30 gallons per lane mile and then adjust from there. And I'd say it's always better if you're just starting out on anti-icing, it's better to err on the, I hate to say this, but start at the 30 and then work your way back. Salt brine tends to be 20 to 25% greater. It tends to be in that, again, personal experience for me was in the 30 to 50 range. Again, that depends. Is it really, are you trying to get rid of wet heavy snow? Is it dry snow that's just going to kind of blow off the road? But so generally, again, bottom line, mag and calcium are very similar. So again, in that 20 to 30 is a good starting start. I'd say start high, and if you can drop it down, great. And salt brine tends to be, and again, straight salt brine is higher than if you're not using a calcium chloride, a mag chloride, or an ag-based product that might be able to drop the effective temperature down. So hopefully that helps.
Okay, great. Thank you.
Okay.
Steve and Bill.
Okay, we're ready to roll. All right, Bill.
Thanks, Jackson, and everybody for having us here today. It's a great honor and a pleasure to do this for everybody. So we're going to go over the unpaved roads best practices. Let's see. This is our Roads Done Right. It's part of our Roads Done Right presentation we like to offer out there.
Yeah, I'll give you a quick background on myself and we'll move on. I've been with EnviroTech for 14 years. I started as a product developer. I'm a chemist. I work in the lab. My main goal, or I guess responsibility for EnviroTech, is to really understand how our products work in the field. So I'm actually out and about with different agencies like counties, cities, and DOTs. Actually, Bill and I were talking about 7 or 8 years ago when he worked for a county. He and I did some work together, and we kind of forgot we met each other. But my goal is to try to understand how our products work, minimize the amount of products that we have to use to achieve certain goals. And so from those, we've created a list of best practices.
A little bit about me. I was with Douglas County in Colorado for 36 years. I worked with GMCO for 4 years and EnviroTech for about almost 2 years now. So altogether, I've got around 41 or 42 years of gravel road maintenance or some kind of maintenance on a gravel road, either dust control, road stabilization, or just blading the gravel roads. So we'll get started with this. And this is a goal that we all work for, right? In the county and government agencies, is how to build and maintain a gravel road. We're going to go over the road shape and geometry, the best maintenance practices, your gravel road quality, and then treatment with stabilizers and chlorides. So, and we all know this part, right? The benefits of building and maintaining a good gravel road. It makes the gravel road safer for drivers. The traveling public are key to the safety factors. It's better air quality for humans and livestock. In Minnesota, you have probably a lot of gravel roads around farming communities and then the farmers themselves on the roads. It reduces the dust on crops and plant life. You don't want to get a bunch of dust all over your corn and soybeans you're planting out there, right? And it reduces the vehicle maintenance costs. These are good manuals. If you haven't seen them before, this is one that was developed by Ken Skorsev. He helped develop this one and write it. He was in South Dakota. This one's not out for published anymore, but you can find it online. It's the Federal Highway Gravel Roads Manual. But like I said, you can find that one online, but this one is still in publication. So you can find this if you find it online or whatever. It's the current gravel road construction maintenance guide. Again, it's published by the Federal Highway Administration. The keys to building a perfect gravel road, right, is you could have the best gravel in the world, but if you don't have good drainage and can't get the water away from the surface or away from the road surface, your road's not gonna perform the way you want it to. Again, you need to have good road base, and you need to make sure that the material meets the specs and has the right makeup for your area. You also need to have good crown in the road, because if you can't get the water off the road, like I said, you're not going to save your road surface. Good ditches are great, but if you build a ditch, like this ditch is wider than most roads I had in the district I was from, in the county I was from. But I was always told that culvert position was a key part of the ditch. So you could see that culvert is just offline from the flow line of the ditch. So it's just going to trap sediment and stuff, and it's going to make it tougher to keep this culvert open. And it's part of the drainage. You want to keep the water away from the road as best you can. Agricultural areas have their own challenges. I don't know how many center pivots you have in Minnesota, But in Colorado and some counties, we have a lot of them. So you have this center pivot coming around once or twice a day, and he's adding excess water to your road surface, and it's just going to create potholes and stuff in the road for like a short little section that you may have to come back and touch up and just to keep the road in decent shape. This is why crown's important. If the crown is typically the middle point of the road, it's the highest part section of the road. Proper crown sheds the water off the road surface to the ditches and the shoulder. A flat crown won't shed water, and the water will just pool out in the middle of the road and make potholes. So you have a really nice road. You put all the effort and time and work into it to get a nice shape, get a good crown in it. Hopefully you get a good crown in it, but if you don't, you're going to have a whole center line full of potholes. This goes to show you right here, this is more poor surface drainage. You've got water standing down the center line of the crown here. The cars have been driving and you have a wheel right here, and there's a ridge of rocks right here that's holding the water, preventing it to escape off the surface of the road. Here's a picture from a road that somebody spent all the time to haul in new gravel, but they didn't address any of the drainage issues. There's no ditches on either side of the road. And then they put it in and it's a flat crown, because you look at this big puddle you have just sitting in the middle of the road. It's just going to deteriorate your road surface. And you're not doing yourself any favors if you don't do it correctly. Poor crown water can't drain off properly. It leads to just a muddy mess like this. It leads to potholes, deterioration of the road surface. Here's another one. It's just the result of poor drainage, right? The water cannot get off the road. So it's in the middle of the road creating you potholes. It's on the shoulder of the road. Look at how sloppy that shoulder is just because the water can't get off. So traffic won't drive over here. They're going to be driving out here. You're going to have a wreck. It's just a lot of stuff that creates problems for you. Here's another one. They've got a good mix of gravel here. It looks like, they've got a lot of rocks and everything. But right here, they have a ridge of gravel right here that's just keeping it from getting off the shoulder of the road. It won't drain off the road surface. A good crown has a nice A shape to it. From the shoulder of the road up to the crown, you'd like to see at least 6 inches in a 24-foot wide road, but we'll get into that a little bit more here coming up. But we like to see a nice A-shaped crown and not a rounded crown, because we feel that in Envirotech that an A-shaped crown will help drain the water off the road better. So here's a basic diagram of the road surface. You got the center line of the road. Then you have your slope going down. This is where the crown, this is the A-shaped crown we were talking about. My roads, I was never fortunate to have the accessibility to build a shoulder crown onto the road. I just always had to come down, the lane come down, and then it went right into the floor slope of the ditch. And it doesn't have to be a super deep ditch. Any ditch is better than no ditch at all. It's just something to get the water away from the road surface and get it away from the subgrade that you have. Achieving a well-built road depends on how well you grade it. You need to know your equipment and you need to trust your equipment. So the best practices for gravel road maintenance that Envirotech likes to see is we recommend that on a 24-foot wide road, we like to see an 8 or 9 pass method for preparing the road surface. And all that does is it gives you the opportunity to mix all of your gravel pieces together, your binder, your rock and everything. As you're rolling it, it's mixing it. It's like you're a baker baking a cake. You're just incorporating all the material together to get the best outcome for your road that you want to get. And then we like to say, while the motor grader's running, you want to prepare the road surface. to the A-shaped crown, you want to have at least a minimum of 4.4% crown, but any crown's better than no crown at all. And the roller should constantly be working behind the grader once he starts this process, so you ensure the proper compaction. Along with that, you need to have the water truck there, and the water truck should always be in communication with the blade operator so you can keep the optimum water moisture in the road to get good compaction that you like to see, the desired compaction you want to see. This is a diagram from, I think, Steve, this was from the Minnesota Department of DOT, right?
Yeah, I think so.
This is the 9-pass method illustrated. So on the first pass, you want to cut from the shoulder of the road towards the center line of the road. This is where you start establishing your crown. The second pass, you're pulling it from the opposite shoulder towards the center line of the road. The third pass, you take it over the crown, but you want to be careful you do not cut your crown out. The fourth pass, you want to take it down, continuing shaping your crown on the opposite side of the road. And you're taking it to your shoulder. On the fifth pass, you're leaving it on the shoulder of the road, but just enough room to where you can grab it and take it back across the other way. That takes us to number 6. You're taking it from this shoulder of the road up towards your crown to help establish the crown still. You're still working on that A crown that we like to see. The 7th pass, you take it over the crown. The 8th pass, you're taking it down towards your shoulder. And this is, the last 2 steps are very crucial. When I started running a blade, and I wasn't the best operator out there, but I would find that I would get in pass number 8 and I had too much material. And I didn't really give myself the opportunity to take the time to take it back across again. So I would start picking up on the toe. So I had 4% crown on the one side of the road, and I had a 2% or a 1% on the other side. So all I was doing is hurting myself. So if you get to this number 8, the 8th pass right here, if you don't think you're going to get rid of the right amount of material without dumping it off into the shoulder, into the ditch, which isn't going to do you any good there either. If you dump it into the ditch, you're just going to fill it up. You have to decide that you need to start taking it back across. And there's nothing saying that more passes aren't a bad thing. It's just you want to take the time to build the road and get it shaped right. And we have a PDF of this technique, and it also shows a 5-pass method for roads that are 20 feet or narrower. And it's just a guideline. It's just what we kind of like to see to help your road get shaped the way it's going to work best for you. You always want to make sure your gravel's mixed well and you don't segregate it out. Like here, I'm only assuming, I wasn't on the job this day, but I can only assume that they may have had like the Scarfire bits on their grader because they have all their fines on this side of the road and they combed all the rocks out and they're leaving them on this side of the road. And all that's going to do is as traffic drives on that, if you know what this much rock does when you leave it in a lane, it's just going to grind up your surface and it's going to start creating more dust and your surface isn't going to last as long as you'd like it to. When I started running a blade or operating a blade, this is a slope meter that I found in the grader that I had. If it had a slope meter, I can remember one of the blades, I ran a galleon for a while and it didn't have a slope meter. So I just had a little torpedo level and I would just put it up like on the windshield where the window seams were on the front window. And if it had a half a bubble to fall in the grader when I was in it, I figured that was pretty close to a 4%. And then I got to where you could see, you know, as you run the blade more, you can tell about what your crown's going to be. A lot of the newer blades have this electronic stuff now, which it tells you what your slope is. You could just, I mean, you guys run the blade, you see this all the time probably in the newer graders. Here's just another version of it. I mean, trust them, they're calibrated. And if you haven't checked your calibration, if you get a hold of your dealer, your vendor, I'm sure they can tell you how to calibrate it or to check the calibration on them. This is the A-shaped crown that we were talking about. So from the center of the crown here, the cross slope to the shoulder of the road here, for a 4% crown in a 24-foot wide road should be 6 inches of fall. And that just helps sheds the water faster. Some counties and some agencies go steeper than that. There's some in Colorado, for instance, that'll do a 6% crown. That's a little excessive for me, I think. I mean, when I was doing that at the county, some of my blade operators would put it in at 6%. And what we found is all the traffic stayed out here in the middle of the road and they just beat the crown out until it got down to where they could drive on the shoulders. So that's something you want to be careful of too.
All right. Okay, so I'll talk a little bit about road base. What we try to do is when we're working with counties and DOTs, if it's a new customer and it's a potentially a high mileage customer, we do a lot of work in our lab and we'll analyze your road base. And what I will say about that is if you've never had your road base analyzed and you don't really understand things like plasticity, do you know what type of gradation you have when you do a sieve test? Are the load bearing material, are the rocks fractured, or are you using a lot of river rock, that type of thing. So you need to understand that. So when it comes time to amend your material, you know how to do that best. So I'll show you some photographs. This is Envirotech's soil analysis lab. It's where I do a lot of the work in the lab for our customers. So what we try to do here is understand the road base that comes in. Right now, I think I have road bases that I'm analyzing from about 8 different counties across the country. So we can understand how our products work in those road base types. So we will look at things like sand equivalency. We'll do some unconfined compression testing as well on material that we're looking at doing stabilization on, this equipment back here. We've got some abrasion testing that we can do. There's a piece of equipment we can do abrasion testing as well. We also want to make sure that the road base meets minimum standards. So we'll do things like gradation testing, plasticity index testing, and we'll do your standard Proctor curve and do optimum moisture. So we know what basically the road base needs to achieve its optimum capabilities and increase longevity as well. Okay, so what we do, if you've not seen these types of molds made with your road base before, you can see these two are incredibly different. They're actually both from Texas. One is from Grimes County, and this is from a pit. And if it looks a little green on your screen, you should see it in person. It's actually like, I don't know, it's almost like teal. It's the strangest road base I've ever seen. But anyhow, we take these molds, we use this loader back here, and we will do unconfined compression strength testing. So we'll put products in here and test different types of stabilizing products to see how we can increase longevity in road base. And if the county that we're talking with has several miles that they're looking at doing stabilization, we'll take a couple buckets, 5-gallon buckets from those counties, and we'll do these types of tests for them in our lab. Okay, so there's a lot you can do in the field that will really assist you in understanding your gravel. There are tests you can do, for like optimum moisture. How much moisture does it need to get to a point where you can create a ball like this, plasticity? And if you're curious as to what type of test you can do in the field, the Army Corps of Engineers actually have a really good document. You can look it up online. and it'll tell you how to do some of these tests. You can actually do plasticity testing if your road base has enough clay type material in it. You can do it in the field. So there's a lot of different things that you can do in the field, and there are a lot of different things that affect your road base, like your ADTs, how much traffic, what type of traffic do you have, what kind of climate are you in? There are places in Colorado that get less than 12 inches of rain a year, so it's almost desert-like. So we have to be aware of these things when we start talking about different products we can use in the roads to help with longevity. And all of the things that Bill talked about before, and he'll continue, I'll pass the mic back to him, and we'll talk a little bit more about things that we do to improve the roads, but chemical treatments can really make a difference. So we'll do sieve testing. This was a test, and I show this one because it's hard to tell, but it's lacking in the mid-range here. When we did a sieve test, you can see this is the 3/4 inch, and there is no load-bearing material at all in the 3/4 inch for this road base that came in. And I should have put up the actual curve, but it's lacking. It is not considered a good gradation for road base. It needs to have some of these materials that would be in this pan and these two pans. It needs a little bit more, and it also needs some load-bearing material. So our recommendation was some mid-size rock needs to be added and some larger rock to this material, and then it would become a good base to build a road with. So we also do other tests, plasticity, I talked about that. We use a little bit more advanced methodology for testing the liquid limit. It's a cone penetrometer we have found, and there are papers written that show that it's more consistent, it's a little more accurate than using the old school technique. This is a graph of one that I did here recently. R-squared value tells you how close you are to a perfect line, and we're 0.97 is pretty close. 1 is perfect. So it has very reproducible results. This is the old school method. It's called a Casa Grande device. If you've ever seen this or used it, it works really well. It's just not quite as accurate. So the one point that I didn't make, and I'm not going to go back to the slide, but you saw these threads, and that was the plastic limit. And so from those two tests, you take the liquid limit, you subtract the plastic limit, and that gives you the plasticity index. So when we're working with materials, actually what we're looking for in a plasticity index, we're looking for something between 2 and 12. And our products that we use to stabilize roads, and when roads are built, we actually are confident, as long as you have a plasticity of at least 2, that we can help build some longevity into your road. We also look at optimum moisture. It's a Proctor curve. This is an ASTO T180, which is a modified Proctor. But this was a road that we built for Chevron with material from a pit called J2. And this material has an optimum moisture around 8.5, which means it has some clay. In Weld County, Colorado, we have very sandy material, and the optimum moisture in Weld is around 6, so it's a lot less moisture. So it helps you understand when you're working on a road not to put too much water into the road, but most of the time, blade operators know when they're close to optimum moisture when they've been working with a road. All right, I'm going to hand it back to Bill for this.
So this was 3 years ago now. We were doing Roads Done Right class in a county in Washington, and they had this road is a lot of that basalt rock. So it's got a lot of 3/4 minus rock in there, 3/4, 5/8 rock in there, and a lot of like crusher fines in it. So this account manager there that was setting up the class, he worked with the county, the district. They used 2 pits that district had access to for gravel. One was the Fry pit and one was the Berg pit. So he had an engineer come in and he brought him on board. They went to each pit and they took a 5-gallon bucket from each pit, and they took it back to the lab and did their analyzing on it, like Steve just explained. And he came back with a mix for us, and he said that it was his knowledge and stuff and his recommendation that we did a mix of from both pits. But you can see right here, you've got all this unraveling because there's just no clay in it, no binder to hold it together. So it looks good when you lay it out at first, but the more the cars start driving on it and stuff, they start moving the rocks around, and then things just start moving around, and you get a washboarded road. So right here is where this was past where they did the re-graveling of. And this is what the road looked like. This is the 50-50 mix from both pits. They took it to their yard. They dumped it 50-50. They did one bucket of each one into a pile, and they just kept mixing it and sending it out to the road. So you can see the contrast between the two road surfaces. This is a basalt rock that wouldn't pack down or seal up. And this is what it looked like after the mix. And here's another picture of it. You've got a nice tight surface here. The shoulder on this side has a lot of loose rocks on there, but the next slide I'll click it to, you'll see why nobody wants to drive over there. So this is the river, and this is a steep bank slope right here. And so they kind of stay to the middle or just to the right of the road. But you could tell the difference there, what a good gradation and a good mix will do for you. And it just makes your life, and it makes it a lot easier because it's a lot easier for you to maintain that road and get a good seal on it and a good cap on it. Not enough plasticity and the roads won't hold together, and too much plasticity and you get roads that look like this, that every high school kid with a four-wheel drive pickup knows where this road is, so they could go splash around and play in the mud on it. Tools to achieve the proper shape and compaction. Of course, a motor grader's key. Carbide steel bits are, they're a good help. And then you have the stinger bits. If you've ever worked with the old soft butter bits, I used to call them, they're just a really soft steel. After you grade the road a little while, you'll get crowning in the bits. If you have that, you'll never get the A-shaped crown you like to see, on a road to get it to shed the water good. Sorry about that. But you get a little crown, so your roads will look like you have a scallop shape. There'll be 2 or 3 little humps in each lane from the crown in the bit. So that's why we like to say the carbide steel or the stinger bits. And the stinger bits just make it a lot easier for the grader to cut the road if you have a good hard road. And then we like to also see a pneumatic roller or a steel soil compactor roller. A walk and roll attachment is a great use. It's on the back of the grader there, and it's just another great tool, and it doesn't cost as much as the other rollers, but you get the same effect from it. You get to see it, get the good compaction you'd like to see on the road. This one looks like it's like a 10-wheel offset. All these wheels are offset. You probably all see them, and you probably have some in your area. And then you have the 8-wheel pneumatic roller, and the wheels again are offset on this one, so you get everything sealed up nice. And then you have the steel soil compactor roller behind it that's vibratory. This one gives you a nice finish, and this one helps increase the compaction when you're working the road. This is the equipment that my crew used in Douglas County. Those other 2 rollers were the rollers we used. And we had a 3,500-gallon tender truck here. There's a hitch between here and a hose. And this cat has a computer system in it, so they can adjust or tell you how much material they're drawing from this truck and injecting into the road as they're grinding it. So what that does is, if we would grind everything 3 inches deep, and we do it at a 0.3 application, so you're putting 3/10 of a gallon per square yard per inch into your road to get the compaction and get the driving surface stabilized. Weld County had two of these that's called a razor mill. And it's a 14-foot mill, I think. It's got its own little power pack on the back. They sold these and got rid of them because Weld County is a pretty wealthy county in Colorado. They have a lot of energy drilling and stuff going on. There's oil, natural gas, a lot of some solar farms and stuff, but they run 4 soil stabilizers now. I think they've got 2 Wirchens and 2 cats that they run.
Yeah.
And they run in 4 crews nonstop. They started dust control in Colorado already. Weld County is the first one to start. But it's unreal how the amount of miles that they treat in a year. On these, there's 4 pictures of road surface here. This one's got a nice seal towards the middle. It's capped really well, but it has some loose rock here. This one, all the traffic's driving on this side of the road because you can tell all the loose rocks are ending up over here. This one's got a nice tight seal on the road. You know, this is a really nice one. And then this road, there's some wheel ruts started in it already. So I don't know which one of these you'd like to pick, but this is what a good sealed surface looks like. All the rock is embedded and encapsulated in the binder on the road that we like to call it, and you have a nice tight seal on it. It's enhanced with mag chloride, and this is 9 weeks after the application was done. Pulling shoulders is a highly argued practice in the industry. We used to run some of these. We had one of these, and in Colorado, I was in Douglas County, and we had what was called the Cherry Creek Water Basin. And Douglas County had some of the strictest stormwater guidelines in the state of Colorado, I think. And our guys that were in the stormwater department were really aggressive on people going out and disturbing this much soil, this much vegetation on the shoulder of the road. If we ever went out and destroyed the vegetation like this, we had to reseed it and bring it back. But the downfall is some people will take this vegetation, they'll do it like this, they think they're killing it right here, they bring it up, they bring it over, they mix it into their road surface. So you're contaminating your road surface. You're putting all this organic matter into it. And that's going to do 2 things. One, it's going to absorb the moisture and just hold on to the moisture in the road to where you can't get it compacted well. And then not only that, as this goes, if you have any big clumps of roots and stuff in your road with this incorporated into your road base, as it decays and it rots and goes away, you just buried a pothole in the middle of your road that's going to give up at some point. Knowing when to and how to pull your shoulder is crucial. In the spring before the vegetation gets established, you know, like right now would be a good time to just go out and barely brush your shoulders and pull your material back in. I mean, no matter how hard I tried when I was plowing snow with a grader, if you get into a road that has a lot of rutting in it, and you can even leave the blade up, but at some point you're going to turn the corner, you're going to get out of the lane a little bit, you're going to pull a little bit of the gravel off the road, and you're going to dump it off on the shoulder. It doesn't hurt anything to just do a lightly brush on that and pull your rocks and your gravel back up and blade the road. But you want to do it before the vegetation gets too big, too tall, sorry. And then you don't want to be over aggressive on it and pull a lot of sand and clay and mud up. Not only are you pulling up car parts and stuff that get left in the ditch from people crashing, but you're going to contaminate the road base you have, and it's just it'll decrease the lifespan of your gravel road.
All right, so you've made this great gravel road. You've got the shape that Bill has been talking about, that A-shaped. You've got a 4% grade. Your crown is perfect, and you don't do anything other than that, and you've treated it with water and you leave the road in great condition. So what happens to that road? Well, studies have shown that one car traveling every day on a road that's untreated, chemically untreated, loses 1 ton of fines a year. Okay, so when does that road actually break down? Well, we've done some studies and done some calculations, but to make it simple, it takes about 75 cars driving on a road every day for a year to take a great gradation gravel and destroy that gradation by removing so many fines. You have nothing left but mid-size gravel, pea gravel type gravel, and then it all just decays and ends up in your ditch. So if you are working diligently to create fantastic unpaved roads and there's no treatment on that roads and you spent a lot of money on gravel, if that road has ADTs of 80 or more within a year, that gravel is gone. Okay, so what do we do about that? All right, so there's all sorts of things that we recommend for the longevity when you're using different chlorides on the surface. Talk about preparing the surface before an application. The road has been shaped, everything is fantastic, it's very well compacted. Mag chloride and calcium chloride are charged particles. The water has charge, and so does the surface of the road. And the surface of the road will repel mag and calcium, but a light shot of water before you put mag or calcium chloride down neutralizes that surface charge in the road. So it makes it seems unintuitive that if we water the road first, that mag and calcium will actually absorb quicker, but they do because they're not fighting the surface to absorb the road because those charges are neutralized. Okay, so I'm going to show you a bunch of different applications. This is actually on a job that Bill and I were on recently for a large oil company outside of Greeley, where we're at right now. But we were doing some stabilization, excuse me, with some different products. And this is actually a large oil pad. It looks like a road, but we are doing stabilization and we treat that surface. This is all road based on this oil pad. We treat that surface like we would a road and apply chemicals to it. And the whole concept is to make the road, to make the area more stable. It preserves the aggregate. After we're done in compacting the surface of the road or an oil pad, we have to do a lot less blading. There's less man hour on maintenance on these areas. And one thing that's good about putting a product like this into the road, there is some chloride, so it helps maintain dust as well. So this is a stabilizing product that we're using on this surface. This is actually a road in the oil field area that we were in. This is a mag-based enhanced chloride, and so we have gone through and done the stabilization on this road. And when Bill and I were out here on this job, this was what, 9.5 miles?
Yep.
Yeah, we did 9.5 miles in a day on this road with what was it, 6 truckloads?
Yep.
Six truckloads of product that we were using on this road to maintain dust control. Like I said, it's an enhanced chloride product. It has the ability to attract water at night to keep the dust down. And also the enhancement helps shed water off of the road so it doesn't absorb it into the surface and beneath the surface of the road as much as well. So what we tried to do with these products, since they're enhanced and they stay on the road better than just mag or calcium by itself, we can use less product when we apply it. So we're actually using less chlorides. And in the state of Minnesota, we have an enhanced calcium chloride product that we use that we can basically shoot app rates that are much lower than if you just go with straight calcium chloride.
And the absorption part of it is a lot. I mean, the lane on the left, as you can see in that picture, was shot already, and that's how fast it absorbs in. So it's not detrimental to the traveling public at
Yeah,
all.
and actually, when we started the application in the morning, there's a check-in gate to get into this facility. Everybody has to check in. So what I did when I left, I asked the controller at the gate of the facility, I said, how many trucks have been through here while we were doing this? In the time that it took us to do the 9-mile application with our trucks, there were 150 trucks in and out of the facility, either bringing in frac sand, water, or just bringing in equipment to the different pads. There are 9 pads on this facility. So it's a lot of traffic all day long. We were able to do the application while the facility was open. Okay, so I'm going to go through and show you, this is a county in Colorado. It's not like Weld County. It has a very low population. They don't have a lot of money, but they wanted to try stabilization because they have some very heavily trafficked roads because of all the farming equipment. So this is Elbert County, Colorado. We did a half-mile section to try to show them that the stabilization was worth their effort. So this is a little half-mile section that we did a test several years ago on. This is one of our trucks applying the stabilization product to that road. Let me go back real quick. It's kind of hard to see in this photograph, but if you notice all of that windrow look material that was on the previous slide, there's a lot of traffic on this road. It has an ADT of about 150. So we didn't close the road to do this work either. And so we were able to build the road, shape the road, and this motor grader is in the process of doing probably its 8th I think it's on its like 8th pass on this section. It's laying out the material like Bill described earlier, and you can see that we have been using a you can kind of tell it's a pneumatic roller, but that's what they had. They didn't have a steel drum, but you can see a little bit of wheel rutting from the compactor here on the road. Okay, so after the road is complete, we used an enhanced mag chloride on the surface of the road. All these bubbles are coming up because as this enhanced mag chloride is absorbing into the surface of the road, it's filling all the voids in the surface of the road, and that's why it gets foamy. As the product is absorbing into the surface of the road, it's replacing all those air voids, and it's making a I hate to say hard surface, but eventually with traffic, the surface will become very hard. Okay, so this map actually shows different jobs that we've done like this one. Albert is actually right here. That's where this road is. I'm going to play this, and I set the Zoom sharing up so you guys can hear this. If something happens and you're unable to hear Monty here in a minute, basically what he says has kind of been transcribed right here. So let me see if I can get this to play.
Hey, it's Monty at Elbert County. Hey, it's 8:45 on Monday morning. We had last night roughly 7 inches of rain on where you put that baseline product, and we have roads washed out everywhere. We have asphalt roads that are gone, and I got to tell you, this road doesn't even have any fingers running down it, nothing. I mean, it just looks pristine. So have to see how it keeps doing after all this rain. But right now, the structure of it is probably better than any road we have anywhere. So just thought I'd let you know. Not going to pay any extra if we do this in the future. Talk to you later. Bye.
Okay, so if you heard that, I hope you did. Monty was describing how well the road held up. So the first year, which was 2023, so 3 years ago, we did a half a mile with them. The next year, 24, we did 2 miles. This last year in 25, we did 5. And they didn't think they could afford a mile. Now they're doing 5 miles of road because the stabilization has improved their surface of their roads so much that they don't have to get back on those roads and do any maintenance on them throughout the entire summer season. If it gets dusty, they may have to come back and do another dust application, but the road is holding really well. So we're going to end here shortly, but this is kind of something new for us too. This started for us last year, but have you considered paving over the surface of a stabilized road? The county that Bill came from is one of the most progressive unpaved road surface treating counties I've ever worked with, and they do. And this was from last summer, and the road that is unpaved was stabilized, a week before we did this? Yeah, so the previous week, they did a stabilization of the unpaved road, and they hired a company to come out and pave it. So there's a couple things that are interesting about this, is that most of the time, counties are doing different types of stabilization, like cement treated base. They used our product, which is incredibly cheap compared to cement. And so they found that with cost savings and the stabilization they were able to do, instead of doing a 5-inch asphalt lift with the stabilization underneath pavement, they went from 5 inches to 3 inches, which is a 40% saving in asphalt. And then you can just imagine how much the cost savings is there. It's pretty substantial. So we've got, what do we do? 5 miles?
Yeah.
So with Douglas County, we did 5 miles, and they're planning on continuing this program in the years to come, which is great for the county, not so great for us as a company, because all these roads that we used to treat dust control and help them with stabilization, they're all getting paved. So it's great for the counties. Obviously, if you guys know asphalt costs, it's not cheap, but there are other options that you can use. And they found that this method they're using with a 3-inch lift is actually cost equivalent or even cheaper than chip sealing. So it's pretty great. Now, that's the end of our presentation. We're pretty much on time. We're able to take questions if anybody has a question.
If I could mention something too real quick, one of our other bigger counties that we deal with is El Paso County, and they've taken some chip seal roads and they've reground them up. And then I know in Minnesota, a lot of you probably do some chip sealing too, but they chip seal over the product too, and it works really well too.
Yeah, it doesn't have to be paving. Paving is just new for us with the engineers figuring out how to do all of this kind of work. All right. Thanks for your time.
Thanks.
All right, guys, I see one question in here. This was from about 12 minutes ago, and it was about reclaiming gravel. Dave is asking, so your recommendation would be to not reclaim, but rather selectively pull back gravel?
Yeah, I think, well, you've got to know your road. I'll use Weld, where we're at right now, what they do. Since we're such a desert climate, we're not like Minnesota. We don't get quite as much rain, so we don't have as much vegetation growing on the side of the road. So what they will do is they will do a little bit of both. They will pull gravel from their ditches, and because what Bill described before, they have 4 reclaimers, and so they'll pull that gravel back and then they'll reclaim it because they can. I think what Bill was discussing before, you have to be careful if you've got vegetation, and then you also, if you get a lot of gravel that goes into your ditch, you want that back on your road. But if the gravel's over there because the road was untreated and you lost all your fines, it's just going to end up back there quickly again if there's no fines to hold it together. So you have to understand the base.
Yeah, exactly. Because when the rocks go out and you bring them back, if you get the dirt and the sand and stuff that's in the shoulder, that's not what was in the gravel mix when it was designed. So it's never going to work the same as when you get it from the quarry. You just want to try to help reduce your costs as much as you can, and not putting in a lot of organic matter into your road will just make your life a lot easier in the long run.
Alrighty, next one here. Zachary's asking, I have a large gravel parking lot that sees 2,000 to 3,000 cars per event. We do roughly 20 events a year. Otherwise, the parking lot is closed to the public. What product would you recommend for dust control, and how often should I be doing it?
Well, I'll start and then Bill can finish. You want to make sure that your gravel parking lot has drainage. I mean, that's always going to be an issue. Um, I'll use a frac sand company here that we've worked with. And, they had, when they built it, the size of the frac sand pad that we built was 200 feet by 1,500 feet. So it's large, like a parking lot. But they set it up so it would drain properly. So what we've done in situations like that, it depends on your budget, but for the frac sand company, we stabilized the material and then we treat it with an enhanced chloride product. We have products, either calcium or magnesium, that we can treat the surface with. And as far as how often you have to treat, it all depends on traffic and weather. If you have a season of low rain, just enough rain, then the product's going to stay quite a bit. If you have heavy rain, one thing that we say about mag and calcium is that the salts like to follow water. So if you get a lot of rain, the mag and calcium are going to follow that water. And if you have good drainage, it's going to drain off your pad. If you have an enhanced product that helps shed the water, it will stay longer. So really what you need to do is there are our sales people, I guess, account managers, they can consult with you. And it really depends on where you are. Now, I'm assuming most of you guys are in Minnesota, since this is a Minnesota LTAP presentation. And calcium chloride is kind of king in your area because of the logistics of getting it to you. That's important. I mean, I can sit here and tell you how great mag is in Colorado and how fantastic it works for all of our customers, but it's expensive to get mag to Minnesota relative to calcium. It has to do with where the sources are. Calcium comes out of Michigan. Most of the mag that we have comes out of Utah. So, less shipping means more affordable cost for you. So there's not one specific answer. We do recommend, no matter what type of chloride that you use, that we have different types of enhancements that we can add to those products that make them more functional and give them longevity that just mag or calcium can't do by itself.
And from my perspective too, it depends on the material that's there too. In Colorado, a lot of people will put crushed millings down in for parking lots. I would say a 2% crown on the whole thing would be great. But if you have millings, you need to probably look at a different material like the base bind material, because calcium chlorides and mag chlorides don't always work really well with dirty reclaimed asphalt. Right, Steve?
Yeah.
So,
it's true. I mean, so there are a lot of questions that need to be asked to get to the optimal answer for you. So just so everybody that's on here, one product does not fit all. I mean, for us, when we talk to customers, if there's a budgetary crisis, but they absolutely have to do dust control, we're just going to recommend a mag or calcium application because it is the least expensive thing that you can do and control dust. And it's dependent, like I said, on traffic and weather. To give you guys an idea of what I'm talking about, longevity, we used to do a 3-mile stretch, which we helped them stabilize, and now it's been paved. But there's a 3-mile stretch of unpaved road that was a cutoff between I-25 and 287 in northern Colorado. And that road would receive between 4,000 and 6,000 vehicles a day, with almost 1,000 of those vehicles being 18-wheel trucks. So you can do amazing things with stabilization, building a road, and dust control as well.
Okay, thank you guys. To everybody listening, now is the time. If you have any questions about other products or any of the material that was covered today, please submit your question. I don't see anything else coming through. Guys, do you have any final remarks?
Thank you, everybody, for your time. It was a great opportunity to do this, so.
I have one last statement. Okay, at the beginning of the presentation, we talked about a Roads Done Right program that Envirotech and GMCO have done for the last few years. We are going to be doing one of these in Idaho in March. These are available to any county that's interested in possibly doing some stabilization, things like that. And we actually show up. The one in Idaho is going to have about 150 attendees, and we'll go out and do a demonstration on a road with utilizing products and the equipment. So if that's something that you're interested in, please let us know. We'd be glad to help you guys out and do whatever we can.
And I'll just add too, we do winter maintenance training all over the country and stuff. So if you have your county, city, whatever, wants winter type training, let us know. That's again, Steve, Bill, and I. That's what we spend a lot of our time is dedicated to training and sharing information with folks. So we'd love to do it, and if we can help, let us know.
Okay, final thing for me. I just put it in the chat here. Please send an email to mnltap@umn.edu if you'd like to receive Rhodes Scholar credit for today's webinar. This webinar was recorded today and will be uploaded on our website in about a week or so. So if you would like to circle back, you're absolutely able to rewatch this webinar when that is posted. So with that, I would like to thank everybody for tuning in today. I'd like to thank Mike, Steve, and Bill for their expertise, and have a great rest of the week, everybody.